Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain clubrooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30pm local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night, and welcome back. We had a bit of a break last week, and I've got Rex VK7MO in the studio. Hello, Rex.
G'day, Justin.
How you going?
Pretty good, yes.
Excellent.
The winds have stopped.
The winds have stopped. We were talking about this. We have had horrific winds here for, what was it, 16 of 20, the first 20 days of October. It was just off the show. But anyway, now before we get underway, I wish to acknowledge Tasmanian Aboriginal people as the traditional owners of this land upon which we're presenting today, and pay my respects to elders past, present and emerging, for they hold the memories, the knowledge, the culture and hopes of Aboriginal Tasmania. Now, the reason why I've got Rex in the studio is for a special presentation.
Yes, the word Metox is written up there, and the reason I've written that up there is I remember when I first joined the Weather Bureau, there was a piece of equipment used for tracking weather balloons called a Metox.
Okay.
And the other day I was looking at some World War II YouTube videos, and they talked about a Metox radar detector.
There you go.
And I thought, what is the relationship between these two things?
Okay.
Now, I remembered this Metox radio satellite as being French.
Right.
And I thought, why would the French be building something for the German submarine to detect British radars?
Okay.
And of course, the reason was
the
Germans took over France and made their electronics
for a few years there during World War II.
Can't they? Now, the interesting thing about this Metox was it was designed to detect the British radars. And the British radars in those, they were called an ASV2.
Okay.
An ASV stood for anti-submarine vessel or something like that.
Oh, okay, okay. Yeah.
No, airship vessel.
Right.
Radar.
Okay.
So, and it was on 200 megs.
Right.
which is extraordinarily low for radar.
Very long wavelength.
But when you remember, chain home was only on 40 megs. But you imagine the antennas that they had for chain home.
They were huge.
They were huge.
They were huge arrangements along the coast.
And this radar had to work on an aeroplane
Okay.
at 200 megs.
Yep.
So before cavity magnetrons
Yeah. Yep.
well, they were aware of them, but before they got them into production and so forth.
Yep.
And the way this thing worked was the submarines had to come to the surface to charge their batteries to run their diesel generators, and the aircraft could fly around at night and see the submarines on the surface, and
and bomb them, I assume.
and drop depth charges all around them and stuff like that.
Okay.
Now the problem was, as is described here, is when the aircraft got more vertical over the submarine, it was getting all this sea clutter, which obscured the actual echo from the submarine.
Okay.
But they could get close to the submarine, and then they used a very high-powered searchlight on the aircraft.
Okay.
And so...
And found them.
Okay.
Okay.
And apparently the Germans decided that the solution to this problem, I don't know how they figured it out, was to put a little 200 meg receiver on
and listen for their radar
and
signal.
listen for the pulses.
Yeah.
And the other thing that was apparently interesting is that when they got closer, they had to change the pulse repetition rate to isolate.
Yep.
And when the Germans heard the pulse repetition rate change, they knew that
they were close.
They were coming close, and they had to dive and and react. So,
okay.
This thing was called a Metox radar detector, and it was built by a French company in occupied Paris.
Yeah. Yep.
Who, after the war, produced what I was interested in or started to use, a radio satellite for tracking radiosondes and balloons.
Okay. So this was the radar tracking of the radiosondes. This was that equipment.
That's right.
Yeah. Okay.
Now, the way the British ultimately overcome this, they used their cavity magnetrons to bring their radars up to 3 gigahertz.
Yes.
And these things didn't work.
Yeah.
I mean, you'd think they could have developed something that worked at 3 gigahertz, but perhaps it took a while before they knew. So
they hadn't stolen the cavity magnetron plans yet.
Yeah, I have had a listen to the stories about the cavity magnetrons. The Germans actually had understood about the theory of cavity magnetrons.
Yep.
But they never found a way of producing them in quantity.
There you go.
But the Americans did,
Yep.
by stamping out the copper cavities.
Yep. Very similar, actually very, very similar to what was used in production microwave ovens. Same manufacturing technique.
Right.
That was one of the other valves I was going to bring tonight, but I didn't.
Okay.
So
now, the Germans actually had to have an antenna on their submarines.
Yep.
And they mounted this on the conning tower. And the British called it a Biscay cross because what they were doing is they were surveying the Bay of Biscay to see whether the submarines were leaving their French ports.
Yep.
I don't quite understand what this antenna really is. It seems to have some sort of
feed line up the middle. But one side sort of goes up here and the other side goes in a sort of a dipole arrangement, so not sure.
But this was the antenna. So,
okay.
Now the British radar, they say here, when they could detect a submarine up to, I think, 58 kilometres, but when they got closer, they had to change the PRF.
Yep.
And then when they got really close, they had to use a light.
Right.
But the U-boats, before they used the light, the U-boats used to crash dive before, because they heard the frequency change and they had,
pulse rate. Yeah.
But by using the light, which was directed by
Somebody, some poor person on the plane hanging out the side of the plane or whatever.
I don't think it was that. They said it was actually steered by the radar. So.
Oh, okay.
So it sounded pretty,
Wow. Okay.
So this was called a Lee light, and
Humphrey de Verde Lee.
yeah,
I love it. The Lee light, a powerful.
Now this was what I remember, but it's not exactly the same.
Okay.
As a Metox, and this was manufactured by the same French company just after the war.
Okay.
Which I find a little bit odd because the MET seems that so they were into meteorology before the war.
Yeah.
But as far as I can tell, they never made a Metox radio theodolite until after the war. The only example I can find on the web is this one, which is a bit different to the ones I remember. But basically, it's got 4 antennas, which if you look carefully, I think they are helicals.
They're helicals. Yeah. There's a coil of wire around each of those stems. Yeah.
At probably 400 megs.
Okay.
Certainly the ones I remember were at 400 megs.
Right.
But they only had 4-phased arrays.
Okay.
So I think there must have been a change in design at some stage.
And they were actually steered manually by a person?
Yes.
Okay.
And well, there was effectively a mechanical antenna switch that rapidly switched between these 4 antennas and also switched the plates of an oscilloscope.
Okay.
So that if you were pointed exactly at...
It was like in the centre of the...
That's right.
The crow screen. Yeah. Okay.
But the amplitude of these things on the crow would, obviously, if you were off one side, it'd be stronger.
Yeah, okay.
And you had to steer it.
Okay. So you had to keep it basically in the centre or something, or you had to keep it somewhere.
And I think on the first day I was actually taken out to our training school in an informal way to teach me about what I was going to be working on, radio sons.
Yep.
Someone showed me how to use one of these.
Oh, okay. Right.
It turns out one of them actually finished up at Davis Station in Antarctica.
Okay.
And it was there till 1961. Or no, maybe it went... it might have gone there in 61.
Okay.
But anyway, Alan Jeffries remembers
The
thing at Davis.
Oh, okay. There you go.
So this sort of story ties in a little bit with some of the stuff we've been doing on radio
well and truly.
lately. I think one of the reasons why the ones that we used just had phased arrays is they could fit them into a radome that was smaller.
Okay.
Certainly in Antarctica, you wouldn't want to be sitting out there driving it in the cold.
No.
And the other places they used them were tropical places like Leh and Honiara, and I think that was had to be in a radome because it was soaping wet.
Humid, yes. Yeah.
Well, you'd have tropical thunderstorms all the time.
Yep.
So...
a Metox.
I've been able to put together the two meanings of the word Metox. One was a radio satellite, and one was a radar detector for German submarines.
For U-boats. Oh my goodness. Okay. Do they still exist? Do you know if they still exist? That company, Metox. Like
no evidence that I found.
Okay. Oh no. Okay.
My suspicion is they probably existed even before the war.
Yep.
And the Germans took them over.
Yep.
And just the title Met suggests they were doing something to do with meteorology and electronics.
Yep. Okay.
So
fantastic.
That was all I could find out.
Well, that is fantastic, Rex. And there's a bit of your history in the bureau and all sorts of stuff mixed in there as well. So good stuff. Okay. Well, that fantastic. Thank you for sharing that. Oh, that's something. In fact, it pretty much sums up tonight, because we've got a whole bucket load of things which are all sort of unrelated, but they're all fascinating. So there you go.
All right.
Can I get you to let Richard know?
I will do that.
So talking a little bit about antennas that potentially could be used for satellite and or radio sons. There is Richard VK7ZBX. Now, Rex and Richard and myself and Murray are all heading to QTech, which is the microwave conference put on by the Brisbane VHF group up in Brisbane on this weekend. So I'm very excited and looking forward to heading up to Brisbane because both Rex and Richard are giving talks, and we're doing a little promo. I'm doing a little promo on Tassie Hamicon 2026 at the end of the end of QTech. So there you go. Now here comes Mr. Richard, who's got a fascinating device that he can tell us about, and it fits quite well with the last speaker in Rex. So yes, hello Richard.
Good evening.
Now VK7ZBX in the studio, regular contributor. Now just I'll hold this. You just stand up and show them your T-shirt.
T-shirt,
please. Yes, the the beatings will continue until
morale improves.
I love it. Okay.
It's a bit of a thing with Hayden's channel that the T-shirts have to be amusing. I've just got a fresh lot from Redbubble, so the boys at QTech will see it in the weekend.
I love it. I just did a promo for QTech, so fantastic. Now, what are we looking at in front of us here? This looks like a propeller.
It does. Look, and look, I'm pretty fortunate that I have a lot of people have 3D printers, and they have to go through a lot of effort to actually get stuff 3D printed. I have a thing called 3D printing as a service.
Yes.
So I have Ken VK7KRJ, who's always keen to show off his prowess at designing things, and like he uses that Open SCAD, which is unlike a normal drafting application where you draw things. Like this is basically you write code to remove the bits you don't want, and
which he has got down to a T.
And he just makes it look just really easy.
So what are we looking at?
So this is a quadrophily helix for 435.
Okay.
So I went down this bit of a road because due to lack of maintenance and a lot of other things, my 70 centimetre Yagi, so my satellite tracking system, appears to have taken on the characteristics of a dummy load.
Oh dear. Okay.
So after tracking
steerable dummy load.
A steerable dummy load.
Yeah,
so I can track the satellites with a dummy load. And guess what? With predictable results. So I thought, really need to try something a bit better.
Okay.
So tried the usual sort of high gain sort of X2000 sort of dual band, tri-band type things, because their radiation pattern is not optimal for satellites.
Yep.
So down the rabbit hole we go, looking at YouTube, and bazinga. These would be really good.
Quadrophily helix antennas. So
happened to be mentioning it to Ken. Goes like, let me print it for you. So he arrived with two. So this is quite a unique one. That it's the traditional design where you've got like a long element and a short element.
Yep.
And basically that provides the phasing to do the circular polarity.
Right.
This one's quite unique that it has to connect the cable, you actually etch a PCB.
So we can actually we have this. And if I do this
Don't look too closely at the etch quality. 'Cause
No.
it's actually done with a
with a Sharpie.
with a Sharpie texter.
That is fine. That is fine. So we've got 4, and we've got the coax coming in, so on connected to either side.
Yeah.
So if you look at this, this is one side of that quadrophilia element,
Yep.
and this is the other side,
side.
and then the other side is
Is there,
connected
yeah.
there.
And it's actually slightly sort of one is I think 110 millimeters
Yep.
across, and the other one's 104.
Yeah, slightly
Yeah,
smaller.
just slightly smaller.
Slightly smaller. Fantastic.
So I'm not quite sure how it's going to look with the V&A. The guy that did the original one did like a quarter wave sleeve belt on the back of it, so he used a bit of Heliax.
Okay, yes.
So he just basically cut a piece of braid
Yep.
and sort of soldered it back along there
Yep.
to act like the sort of to stop common mode.
Yep.
As you quite rightly suggested, now that I've got it all together, I think we might just try like a trombone.
Yes.
To just or some clip-on ferrites. Like,
Yeah. Or just coil it up. So
yeah,
that's the
yeah.
other way of doing it.
So that will hopefully a little bit of a Knievel act to sort of push that down through there.
Yep.
And then that'll be just soldered on top.
So this goes there.
It'll actually go the other way, so the cable will go down through there,
Oh, that way.
and that'll sit on top, so
Yep.
you can solder the top of it.
Okay.
And then I've found a Tupperware lid in my wife's Tupperware collection that doesn't have a container soap.
Oh, dang.
How about that? So that will become like a rain cover that will sort of
Okay.
go over the top. I was going to put some lacquer over that to protect the
Yeah.
copper.
Cool.
And then a piece of 25 nominal bore PVC pipe that sort of basically
Very
will sort of
nicely
fit
fit.
through there. Live on TV.
Yeah. One we prepared earlier.
That will go up there, and then the cable sort of exit the bottom.
Yep.
I
All
was
the
just
way
going to
through.
clamp onto a bit of a mask, going to mount a preamp here, and
I love it. Absolutely love
Robert's your mother's brother.
it. Well, I'll be very fascinated to hear how it goes.
Yeah, I'm really keen because there's a lot of Russian satellites at the moment
Yep.
that are doing the SSTV thing.
Well and truly.
They will promptly finish by the time I get this going, of course. But by using an SDR, hopefully we can listen to like all of the frequencies at once.
Yep. Yeah.
So
I'll be fascinated to hear because we've had one of these on earlier that Ron printed
by the same guy.
the 3 elements the 3 elements and that sadly because that was created for the transponders, so the weather
which
radio
sadly
sond.
are not working anymore. They've all been decommissioned.
So it's still sitting there with the RTL
Do it
SDR.
for 145 or 146 megs, then you can use it for the ISS. So
Correct. So there you go.
I've seen a lot of stuff on the various Facebook groups and things now for the HRPT from the different weather satellites on the 1.7 gigs and some of the K band or X band on 10 gigs.
Yeah,
some
yeah.
of the pictures are really good, but that's
Steerable, steerable and quick.
yeah.
And it has to do 180 degrees.
Yeah, I still think one of the missions we should do is I'd really like to do is the ISS transmit digital DVB-S.
Yes, yeah.
on
Ham
3.3.
TV. So the Ham TV transmitter. Yeah,
So that would be a pretty cool thing to watch.
definitely.
Like you can probably nearly watch the same content via sort of the YouTube stream, but
it would be better to actually receive it
100%.
natively.
100%.
Yeah.
But,
So fantastic.
yeah.
Look forward to hearing how it goes.
Me too. Obviously, I'll be away for a little while because we're going to QTech. But
QTech, yes, and I did the promo, so so yes, and you're giving a talk at QTech?
I am. I'm doing a little presentation on my journey in 10 gig EME.
Love it.
So
Love it.
hopefully it'll be good.
Excellent.
Looking forward to catching up with the guys up there.
Okay. And we've now had 2 of the presenters from QTech on. So yes, I'm looking forward to it, and I'm looking forward to it being quite nice weather up there, and not windy.
Yes, I think all the Tasmanians will be impressed with the weather. I don't know whether
they had a wind event a few days ago, which
Scott Forsey then sent me a photo of a wicked storm cell that was approaching, and he's like, "So here's a photo of what's coming," and he's like, "I might just go and disconnect some antennas," and he sent me a photo like 20 minutes later of blue sky. And he's like, "Welcome to Southeast Queensland."
Oh, well and truly, well and truly.
So.
All right. Well, that is fantastic, Richard,
No worries.
and I look forward to your talk at QTech. At QTech.
Yep.
At QTech. My phone's ringing. At QTech, and we'll do a one of our Wednesday experimenter group nights on QTech and what we thought.
Well, I think it's really
and
good.
a bit of a review. So there you go.
Looking forward to it.
That is fantastic. Thank you, Richard.
Thank you very much.
Thank you. And I do look forward to hearing how that goes.
Well, I'd like to perhaps get the partner of it going. Yours, you can.
Oh no, well and truly. For
Because we all need another
403
project,
megs.
Right? We all need another project, right?
Yeah, we do, definitely do. We definitely do. Thank you,
Plus
Richard.
one.
Thank you, Richard. Now, we've got a huge number of streaming viewers. Hello, Andy, and Matt and Ken from New Zealand. So Andy from the UK. We've got Peter Young, VK3MV, VK7MAT. We've got VK7DBX. Hello, David. All sorts of things going on. Okay, and fantastic for your comments. Thank you. And please, if you've got any questions or whatever else, please let me know. Now, during the week, I found, quite by accident, an amateur radio action magazine. And this particular amateur radio action magazine was from February 1984. So this is a fair while ago, but this February 1984 ARA happened to have a tour of the then Department of Communication, or the now ACMA, Australian Communications and Media Authorities, what they were calling the Big Brother station at Quoin Ridge in Tasmania. Now, Quoin Ridge, for those who don't know, actually out near, as you go to Richard's place at Tea Tree, you go past Quoin Ridge, which is up above on the range, which is in between us and the Coal River Valley. So that's where we are. There is an ACMA monitoring site, which is one of a whole network of monitoring sites, that the ITU have that the ACMA run for a whole range of purposes, including ITU purposes and defence purposes and all sorts of things. And it is a monitoring station, ITU monitoring station. So, and in fact, Peter 3MV's probably got some comments that I'll grab from him on the way through. But this 1984 article actually had a tour through Quoin Ridge, and you can see here there is the building, and then there is a huge open area which has got a whole lot of antenna arrays in it. And these antenna arrays include the original or the modified Baldock type array, which is you've got a central tower and then about 500-foot radial wires that come off that tower in a whole range of directions, and then they're terminated at the end with a 500 ohm load, and you can switch between each of those radials to get a bit of an idea about what direction the signal's coming in from. That was one of the arrays. Then there was a ITU inverted cone antenna. Now, it's a bit hard to see here on this picture, but there are many wires that come off of the top wire that goes around these 4 posts, and they come down in an inverted cone to the middle and to this lower picture here. All comes down to this center point, and they say here that this is used for field strength measurements and is constructed to a very critical standard for the station's international monitoring responsibilities through the ITU. So that was another one of the antennas that was up there. And then we had another tower that had a crossed beam directional Yagi or log periodic, could be a log periodic, on a rotator. So that was a directional VHF, UHF, etc. And then there are some disc cone antennas on this next deck down, and some more disc cone antennas a bit further down, and outriggers and all sorts of stuff. So the VHF tower showing the crossed log periodic array at 100 feet, 4 disc cones array on the outrigger arms at 80 to 90 feet, 85 to 90 feet, and 2 low band disc cones at 75 feet, and the VHF transmitting antenna at about 65 feet on the 100-foot lattice tower. So there you go. So some impressive antenna arrays and ability here. There's some of the disc cones, and the Collins monopole antenna shows off extremely rugged construction, which that particular location would be hit with pretty significant winds, so it would have to be pretty well constructed. Inside the standards room, which is the time standards, all sorts of stuff, talks a little bit about Tasmania's disaster management plan, which amateur radio, up until about 1975, amateur radio figured in the disaster relief plan. But unfortunately, after about 1975, it disappeared. And the reason I know that is I've got a copy of the 1975 disaster plan, which amateur radio features in, and then every plan after that, it doesn't. So that was a bit sad. Now, XY plotter, this is the control, one of the 2 monitoring stations at Quoin Ridge, with, they talk about here the Raycall receivers and antenna switching banks, speakers, and the monitoring crows. The center console showing the attenuator panel, digital signal generator, and frequency measuring equipment, crow and VHF receivers on the far right. So anyway, I just thought I came across that quite by accident, and it was the 1984 view of Quoin Ridge. Now, Quoin Ridge is well and truly still in operation. There was a big upgrade to it, compliments of, I think, the Department of Defence. A few years ago, they put in a whole lot of more antenna arrays, and Department of Defence get to use the facility. It's all I understand it's all remotely controlled these days, so there is lots and lots of net connected pieces of equipment and bits and pieces that you can dial into, and I assume they record in different directions and different frequencies and all sorts of stuff. So anyway, Quoin Ridge, and it is here in Tasmania, just above Hobart, and there is it's interesting reading. If you go down a bit of a rabbit hole, there is the Brighton Council, which is that local council area which covers the Quoin Ridge area, has its planning scheme, which is aligned with the Tasmanian planning scheme, has the Quoin Ridge Radio Quiet Zone. So there are some quite detailed requirements around Quoin Ridge and that particular area, and making sure that it is a radio quiet zone. So there you go. Now, last time we were here, I talked about this little Pico balloon called ZS1ERZ. Now, ZS1ERZ has now been aloft for 75 days. It is, if I zoom out here, it is off New Zealand and in the middle of the Indian Ocean. The Pacific Ocean, sorry. Get your oceans right, Justin. It's in the Pacific Ocean, in the middle of the Pacific Ocean. And there is another one that we've come across, which is ZS1ERZ, which has been aloft for, if I zoom down here, 21 days. So now I reported last time that these were actually launched from New Zealand. That is incorrect. Can I just correct that? I just need to correct it. It actually was launched by the Eden Radio Club in South Africa, and it has been aloft for 74 days and 21 days, respectively, which is absolutely amazing. This is a little balloon with a little payload that weighs nothing. It's running on solar panels. We've looked at the record. Steve 700 has looked at the record, and every time it's in daylight, it is transmitting a whisper signal on 28 megs. And so it is only running off of its solar panels right at the moment. And still being received quite faithfully by many people around the Pacific and around the world as it zooms around. So it's sitting currently at about 13,000 meters, and what's this one at? At 12, yeah, about 13,000 meters in height. So it's, but yeah, absolutely, absolutely amazing, and still going. So I can't believe it. And there's two of them. So when one comes down, hopefully the other one stays up there. But 75 days and 21 days, I just can't get over that. That is just off the show. Now what have we got in for time? Okay, what we might do here, I might just park a few of the things that I had. I had in the description for tonight some special globes. And I wonder, let me go back to our, I wondered if people realised what I was talking about. Because one of the things that I do collect, apart from Morse keys, is interesting valves. Now, these are the interesting globes that I was talking about, and I'll put this here. Let me just go to the document camera. Now, the very first valve that I'm going to talk about here is a Philips TC1/75. So I'm starting with the simplest of valves here. Now, this is what they call a triode. Now, what that means is there is an anode. One of these will be the anode. I don't quite know which one, but one of these will be the anode. There will be a grid, and there will be a cathode. Now, the cathode will be over the filament, and the filament is just literally, and this is where they become a globe. The filament is the thing that you run mostly AC through, and it glows and emits electrons. And it emits electrons, and those electrons are drawn to the anode, which is at a very high voltage. In this case, this runs at about 1,000 volts, this particular valve. And the filament runs on 10 volts and at a current of about 1.6 amps. And so those electrons are generated by the filament. The cathode emits those electrons through the tube, and so it would be in this direction up towards the anode. And the grid, there is then a current that's applied to the grid to control that flow of electrons. So they inject that the signal or whatever they're trying to amplify into the grid, and then they take off a much higher signal, a much higher current up here at the anode level. So dependent on the circuit. That's a very simplified view of it. But this is the simplest, one of the simplest valves that we can get. This is a triode. So it's got an anode, a grid in behind here, and then there is a cathode down the bottom with the filament sitting behind it. So so that's the first of our special globes, and all of the ones that I'm showing tonight are ex-broadcast transmitter valves of some way, shape or form. So this is the first one and the simplest one. The next one I've got is a now this is a bit more of an impressive valve. I can hold this one up. So this is an EIMAC 4-400A transmitting valve, and this is what they call a tetrode. So what does that mean? What does a tetrode mean? And I can't even fit it in the document camera, but you can see this is where this is the anode, and this is where you connect the very high voltage, and this runs on about 4,000 volts. This particular valve, anode voltage. Now, if it's a tetrode, what that means, tet means 4. So what it means is there is an anode. There are a couple of grids in behind this these radiators here, and then there is a filament, a cathode with a filament sitting behind it. Now this filament, the filament for this particular valve, and if I turn it round, you can see the size of the pins here, and here we've got the filament pins here, and the filament on this particular valve runs at 5 volts at 14.5 amps to supply the amount of power for this particular tube. Now this particular tube, you 6 watts in, 6 watts in input power gives you about 1,000 watts output power, or near enough to 1,000 watts. It's about 800 watts, and it's a HF, as with the other one. It's a HF type of tube, so anything up to about 30 megs, or in this particular case, anything below about 75 megs. So this particular tube, and you've got a screen grid which screens the anode, and you've got a control grid like you've got in the triode. So pretty impressive valve. And this has come out of a broadcast transmitter. This was the, my understanding is this was the exciter valve for a much bigger valve. So this was the exciter amplifier driving the main valve in the broadcast transmitter. Now another box. This one's still in the box. So you can see it's an RCA. RCA. Now, this is just a smaller version. This is actually a smaller version of that valve that we just looked at. So this is a what they call a 4-250B. So this is a smaller version of that particular tube that we just had, and the 250 is indicative, the 250 watts. So this you could use that bigger one as a main transmitting valve, and then excite it with this particular valve. So this again is a tetrode. So it's got an anode, 2 grids, and a cathode with a filament sitting behind it, and the filament same. In fact, it's 5 volts at 14.5 amps, so it's exactly the same filament voltage and current for this particular tube. But this is a much lower powered tube. This is only about 1/3 of the power of that other one. So the tetrode. Now the tetrodes, when the electrons hit the anode, so you generate it here through the filament. It comes off the cathode. It's controlled by those 2 grids, and hits the on its way to the high voltage of the anode, which is inside this shield here. One of the problems you have is what tends to happen is you get secondary electrons that get knocked off the anode, and they make their way back to the other grids. So what they actually do, and the reason why they created a tetrode, was the screen grid stops those secondary electrons coming back into that main grid. So the control grid, and so you get a more stable arrangement when you have it as an amplifier. So you get a bit of a distortion with a tetrode, and I'll go into the next valve, which it fixes that particular issue. But anyway, this is a 4250. So what you've got here is about 3 watts in, and you can get up to about 500 watts out of this particular valve. And again, these would have been exciter valves for much bigger driving and power valves. So yeah. Anyway, special globes, and they glow. They have a lovely glow to them as well. And this particular one actually still has the RCA test documents in here. So there you go. So we've gone from a triode to a tetrode. Now we go to actually a much later valve, and this one was pulled out in 2002 from a broadcast transmitter here in Hobart, and this is quite a different valve. So this is a 5CX 1500B. So if I put this here, so this is a fully enclosed valve, and you can actually see here, this is a force cooled valve. So there is a chimney that goes over here, and they force a lot of air through the valve to actually cool it. This whole section here is the anode part of this valve. I think. I'm not quite sure about that, but I think it's the anode part of this valve. So this whole area needs to be isolated. Either that or that's the anode. Not quite sure there, but I'll find out. It has quite a different socket on it. This is like a 60-degree turn socket. You drop in, and there are contacts on each of these. Now this is what they call a power pentode. So pentode, there are 5 elements to this particular valve. So what you've got is an anode, you've got a control grid, you've got a screen grid, and you've got what they call a suppressor grid. Now so where we get that those secondary electrons coming off the anode, what the suppressor grid is right next to the anode, and so what it takes is all of those stray electrons that come off the anode, and they get suppressed, they get taken away before they get to any other of the control or the screen grids under here. So a couple of these will be filaments, and then there are 3 grids, and then there is the anode. That might be the anode there, I'm not sure. This might be the cathode. I'm not sure which way around this is internally. This is a ceramic base, a beryllium base, so we need to be a little bit careful with it. You can also see, I noticed here, and you can see on here, it's got faulty written on it, absolutely faulty, and you can see it is actually arced over. Just here, there is arc damage all around here. So this particular valve failed catastrophically in the transmitter, and so that's why it's been pulled out of service and a new one put in. Now, so you've got filament. You've got 5 volts at 38.5 amps. 38.5 amps. You've got something like about 10 watts in for a 1500 watts out, so 1.5 kilowatts out. It's a HF valve. It does go up to FM frequencies, so it does go up to VHF. And again, it's force cooled. There is a chimney around this where there is a lot of air being forced through this. Cooling air has been forced through these fins to actually cool this valve, and if that airflow stops, then everything gets shut off. There are safeties that shut off the valve if the forced air cooling actually stops. So anyway, that's 4 different valves, increasing in complexity from a triode to a tetrode to a power pentode, and these are all broadcast type transmitting valves that have actually come out of broadcast transmitters of a variety of ages and types. Just part of the collection. So special globes. I call them special globes. Now, how are we going for time? Okay, great. We're on track. Now, space weather report. Space weather, we have had no significant space weather over the last week, so nothing to report there. It's standard. We did have, though, in our training and assessment courses, we had 3 people go through our foundation course and assessment on Saturday, and all three passed, so congratulations to all 3 of them. And in fact, one's up here tonight, VK7 Whiskey Oscar Zulu, so was. So that's Warwick. So if you hear Whiskey Oscar Zulu on air, please go back to them and say hello. He's brand spanking new, basically got his call sign today. So good stuff. So excellent news. We have one more assessment day. So we've got one on the 29th of November. So this is the Standard, Advanced and Regulations Assessment Day. Please, if you're thinking about doing those courses and you're ready to do the assessment, book in, ring or email Reg on the number, and that's on the 29th of November, and then we go into a couple of months of recess to give our assessors and trainers a bit of a rest. And then we kick off on the 21st of February with our first 2026 Foundation Training and Assessment Days. Now, next week we've got something special. However, I have to apologise up front to our streaming viewers because we have been asked not to stream this particular one or record it. So it is Perspectives on Australian Broadcast Radio, brought to us by Phil Tyson from the Sound Preservation Association of Tasmania, SPAT, and he did this particular presentation. I saw this at the Alara meet a couple of years ago, and they've revised and refreshed the presentation, and they're giving to us again next week. So next Wednesday night from 7:30 p.m, but you have to be in the club rooms to actually see it. Then on the 12th of November, we've got an EMR safety quiz night. Now, this will be streamed. So all of those things that we learnt about EMR safety and how to use the calculator and exclusion zones and hazard zones and 6-minute periods and all sorts of stuff, we're going to test to see whether you're up to speed with EMR safety, and we'll have some prizes. So it'll be Kahoot. If you remember our past quiz nights, we will actually have Kahoot all queued up so that anybody who is online, anybody who will see the QR code will be able to participate, and we will have some prizes for people. And then Wednesday, December the 3rd is our end of year sausage sizzle. We'll have 2 barbecues going. So there will be one for the Wednesday afternoon group at lunchtime. So there'll be a sausage sizzle lunchtime, and there will be a sausage sizzle evening meal for the Wednesday experimenters groups. So there will be two sessions, if you like, up here at the Queen's Domain. So please come up, enjoy a sausage. and celebrate the end of the year. We've had a huge year, absolutely huge year. So, and then 2026, the very first thing I'll mention, January the 18th, we have a huge car boot sale and sausage sizzle up here at the Queen's Domain, which is what we normally do in January. So bring along your items to sell or swap. So we go into recess for a couple of weeks. Presentation night next week, and then there is forum night the next week after that. So we will be back in the studio, and I'll go through the rest of the things that I had in a couple of weeks' time. So 73 to everyone online. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night, and we'll catch you next time. 73.